There should be aliens all over the place. So why have you never heard back from a single one of them? If you step outside during a clear night and stare up into the sky, you're merely witnessing a small neighborhood of a much larger city. The Milky Way is an exceedingly old place. This galaxy has been here for over 13 billion years. It houses somewhere between 100 billion and 400 billion stars. Many of them are billions of years older than our own sun. Now let that sink in for a second. A civilization out there would have gotten quite a lead on us. 1 million years, or 10 million, or even 100 million. Humanity only took 66 years to go from the Wright brothers to the Apollo program. So consider what a civilization could achieve with 100 million years to develop technology. And suppose just one of them advanced technologically enough to spread themselves beyond the bounds of a single planet. In that case, they have certainly had ample time to colonize every single corner of this galaxy, and they should have reached us by now. But have a look around you. Do you see any starships? How about a signal? Ruins, megastructures blocking the light from distant stars? Nothing. Surely, you think, this universe is simply too vast for anybody to discover us, and the distances between stars are simply too large for anyone to traverse them. The universe certainly has had sufficient time to overcome distance. So where are everybody? And what if this silence that we keep hearing isn't due to the fact that nobody else is out there, but rather because something stops every civilization out there before they get here? It was summer in 1950 when a physicist named Enrico Fermi met up with his peers over lunch. The conversation was centered around a cartoon featuring flying saucers, stealing people's trash cans. However, shortly after that, it was shifted to the probability of faster-than-light travel and the overall scale of the cosmos. But then Enrico Fermi blurted out a question that would survive even after he did. Where is everybody? Just 3 words, but a gigantic, terrifying problem nonetheless. You see, you really don't have to have faster-than-light travel in order to care about this. You don't have to have wormholes or warp drives or anything magical like that. All you really need is some time and a civilization ready to expand. Consider a civilization that is able to travel from star to star at a small fraction of the speed of light. It builds ships for interstellar voyages, colonizes another planet within this cluster of stars, takes 1,000 years to complete the journey. That colony then builds ships of its own, gathers resources and expands to another system of stars. This process repeats itself endlessly. At first, almost nothing seems to happen. For millennia, such civilization occupies a mere cluster of stars. However, as time goes by, it grows exponentially. 1 becomes 2, 2 become 4, 4 become 16, 16 become 256. And this is the incredible mathematical power of exponential growth. You don't have to move fast. You just need to keep moving. Give some civilization a few million years of this relentless, exponential expansion, and it will have more than enough time to colonize the entire galaxy. Not to mention that the Milky Way has had billions of years to house some life. That is why the question remains. Why can't we see them? For a long time, the solution to this issue was simple. Life is simply incredibly rare, Earth is unique, and the conditions for life here are a miracle. We started sending space telescopes into the sky in order to detect planets orbiting other stars, and we found quite a lot of them. To be precise, we know that almost every star that you can see in the sky has at least 1 planet orbiting around it. There are more planets in the Milky Way than stars. Some of them are gas giants, others are molten rocks. Some are Earth-sized and are situated in the so-called Goldilocks zone. This means that they are at the right distance from their sun, and there may very well be liquid water on their surface. One stellar system in particular attracted a lot of interest from scientists. This is the TRAPPIST-1 system. It includes 7 Earth-sized planets located extremely close to a small and cool red dwarf, and several of them lie in that habitable zone. So it seemed to be the perfect place to finally find something. Until the James Webb Space Telescope pointed its golden mirrors at this system, and took a closer look. And instead of the expected clear answer, they received something completely different. The inner planets lack the atmosphere that scientists were expecting. The outer planets remain completely unknown, and the star itself is extremely active, hurling powerful flares that render our attempts of reading the underlying signs useless. We have not found a lifeless system here. We haven't found a living system either. What we found is another giant maybe. And silence again. And this is becoming a pattern of the entire cosmic search. More advanced telescopes are not simplifying the mystery. Instead, they're only making it more convoluted. Each new planet we scan answers a couple of questions and poses a few more. We discovered complex organic molecules in dust clouds. We discovered liquid oceans hidden under miles of ice on moons of our solar system. The ingredients of life are everywhere. We are not looking at the universe that gives us a resounding no. And we are not looking at the universe that gives us a definite yes. Instead, we are looking at the universe that keeps telling us, maybe, and looking away, which may mean that the issue wasn't in the effort that we've put into the search. Instead, the problem may lay within us. Think about what you actually had to undergo in order to be able to listen to this now. Simple cells had to become complex cells, two cells merging into one without killing the other and becoming the energy source that we call mitochondria. As far as scientists understand, this specific step has happened only once in the 4 billion year history of Earth. Once. Then came multicellularity, specialized organs, nervous systems, and brains. Then, out of billions of species that lived, fought, and died over hundreds of millions of years, exactly one became intelligent. Exactly one gained enough intelligence to ask questions about math, fire, and stars. Then came technology. Agriculture, industry, radio, the ability to make our presence known throughout the universe. Each and every one of those steps was a door. Perhaps all of those doors were left wide open, and life simply poured through. One of those doors is so incredibly narrow that almost nobody that passes through it gets to the other side. Scientists gave this frightening bottleneck a name. It is called the Great Filter. This is a hypothetical barrier that exists somewhere between dead chemistry and a civilization that spans an entire galaxy. A barrier so difficult and lethal that almost nobody crosses it. And this concept transforms the Fermi Paradox into something terrifying, because that great filter can only be in one of two places, behind us or ahead of us. If the great filter is behind us, that means that one of those steps that we have already taken is incredibly rare. It may be a statistical miracle that created life in the first place. The transition from simple to complex cells. The development of human-level intelligence. It means that you don't live on an ordinary planet. You live on the rarest planet in the whole cosmos. We've passed the hardest part. Maybe we are entirely alone in this universe, but we have survived the test. We made it. But what if the great filter is ahead of us? Then it means that civilizations reaching our level of development are not uncommon. They evolve. They become intelligent. They build computers. They split atoms. They learn how to look up at the stars and see themselves there. And then, they do not make it anymore. Something kills them. Without exception. It may be a nuclear war. Total exhaustion of planetary resources leading to environmental collapse. Building an artificial intelligence that they cannot control. Or some other cosmic event that we've never even thought of. Something like a physics experiment gone wrong. Microscopic pathogen. Natural mass extinction cycle. And here comes the scary part. If the Great Filter is ahead of us, then all of those missing alien civilizations are not only absences. They are evidence of what tends to happen to civilizations at the very moment of announcing their existence. If we manage to point our telescope at a distant star and find radioactive ruins of a dead world, it will be the most terrible discovery of human history, because that will mean that the Great Filter is still out there for us, and we will have to figure out whether or not we pass it.